Now hopefully you can remember the rules for trigonometry, sometimes abbreviated to SOHCAHTOA, and they are all about finding out angles and sides in triangles where there is a right angle. What we're going to look at in this video is what happens if we've got a triangle where there isn't a right angle. Here we've got a triangle without a right angle. You must assume that that is not a right angle. And we're going to label the sides A, B and C, and label the angles capital A, capital B, capital C. Notice that the capital A is the angle opposite side A, capital C is opposite side B, capital B is opposite capital B. Now I'm going to draw a line down here and make a right angle there, and then I'm going to consider this triangle here, and I'm going to consider this length here. Let's just label that X. So in that triangle here, X is opposite B and A is the hypotenuse of that triangle. So I can then say that the sine of B is X divided by A. Now let's consider this triangle here. The sine of A is X divided by B. Let's rearrange both those equations, and X equals A sine B, and X also equals B sine A. Now X is the same, so it's the same there as it is there, so therefore that means that A sine B equals B sine A. This is normally rearranged. Let's divide both sides by sine A, and let's divide both sides by sine B, and we get that. Now we can do a similar thing with the same triangle, but draw the perpendicular line here, and then by looking at this triangle and by looking at this triangle we get the same sort of result. So we get y over c is sine A, so y equals c sine A, and also y equals A sine C. Therefore c sine A must equal A sine C. Again, let's rearrange. C over sine C equals A over sine A. But hang on, we just said on a minute or so ago that A over sine A was B over sine B. So all those must be true. It's normally written in alphabetical order, so the normal way of writing this is A over sine A equals B over sine B equals C over sine C. Now that's a double equation. You don't ever use both equal signs solving one. You wouldn't have one problem where you need both of those. You either use that bit or you use that bit. Here's an example. The rule states that the side over the sine of the opposite angle equals another side over the sine of its opposite angle. So notice that the 7 and the 40 are opposite each other. The x and the 60 are opposite each other. So because of that we can say that x is 7 over sine 40 multiplied by sine 60. And that works out to be 9.43 to 3 sig figs. Here we've got another example, but this time it's the angle we don't know. The simplest thing is to turn the whole equation upside down. Sine x over 9, they go together because they're opposite each other, equals sine 35 over 6. They go together because they're opposite each other. So rearrange that and we get sine x equals 9 times sine 35 divided by 6, which works out to be 0.86036465. So therefore x is the inverse sine of that number. That works out to be 59.4 degrees to 3 sig figs.